Good morning. It's wonderful to be here to see such a breadth of topics being discussed. So we are going to run a bit of a tag team, which will be interesting to see how that goes. You'll notice that there are three of us named on the slides. There are three grand challenges as part of this programme, and Julie McCann from the Department of Computing at Imperial runs one of them. And I'm hoping that Jennifer's going to speak to her grand challenge. We'll see. Either of us can, but we'll see how things go. But I actually want to start the talk by talking about the Alan Turing Institute. Because although many of you here will probably know about the Turing, many of you may not, so I wanted to outline a bit of the history of the Turing and how it came about before I move on to the Data-Centric engineering program and then zoom in even further into the kind of grand challenges that we're working on. It was interesting seeing Adam speak in the first talk about a little bit about that kind of some of this how we need to collaborate and think with some kind of moral compass about some of the work that we're doing. And I do think that the Turing provides quite a nice focus for that. It was actually set up initially after a report on the age of algorithms in 2013. And it's kind of turned into work on data science and more recently on AI as well. It was funded initially from a government call where George Osborne, I'm trying to remember, I don't think George Osborne went to Eton. I think he went to St. Paul's. So anyway, but nonetheless, similar kind of issues there, I think, in terms of schooling. So George Osborne, however, having said that, great that he threw a whole load of money at setting up the Turing, and it was also set up with support from EPSRC with that money. Initially, it had 5 universities involved, and another 4 have joined at the end of last year. So there's a real breadth of kind of university involvement and, of course, engagement from funders and partners like the Lloyd's Register Foundation, which are involved in particular strategic programs. And I'm going to also be very careful with my use of the word strategy. So I'm going to just maybe try and avoid talking about strategy. As a statistician, I work in the maths department, I work in statistics, and I'm thrilled that Adrian Smith is going to be taking over as director. He used to work at Bayes, having been an academic for most of his career, then moved into government. He's taking over as director in the autumn of this year, which I think is a great move for the Turing Institute. And I think Turing has a really unique part to play in exploiting data science and AI. I think, of course, because it brings people from all of the different domains that we need to be able to answer these questions. It's not just about the computer science, it's about all the statistics, it's also about obviously the use of machine learning and AI and the domain-specific knowledge. So Turing has a range of scientific priorities, and I mentioned that it was set up from this idea of the age of algorithms. Underlying a lot of this is these mathematical representations of these quite complex systems. And so it has these scientific priorities and works across a whole bunch of research programs that each have a research director, one of which is Data-Centric engineering, which we're involved in, amongst a whole load of other very important areas. So moving on to the Data-Centric engineering program, it's based around, based around 3 grand challenges that we'll talk about in more detail later on, but I want first of all to outline the actual program organization. Now, Mark Girolami, is he here yet? He'll be around. Mark is at the top. There we go. He's going to be on the panel later on. And then underneath that, we have the leadership in terms of the core research of the 3 challenges that we're going to outline. But there are also, under the structure that Mark set up, these group leaders working on some really interesting research projects that I've outlined briefly there. Okay, being very cognizant of the time, I don't want to spend too long on this, apart from to say something I'll come back on to later, is one of the missions of the DCE project is also that education remit, and I'll come back to that later on, and that's led by Omar Matta, who's also at Imperial. Theory is also important, and we have an amazing pure mathematician, Alex Mijatovic, working on the theory and methods. all part of the program, and the idea is that we're all going to be working together pretty collaboratively based at the Turing. The postdocs that are associated with the challenges they live at the Turing, so even though we're all disparate, we all meet there and work together quite collaboratively. Right, and I'm going to pass over to Jennifer, who's going to talk about the first grand challenge.
So this is a grand challenge that's being led by my colleague Julie McCann, who's in the computer science department at Imperial, but it's around resilient and robust infrastructure. And so her interest is in how can we look at a set of problems that we can see as critical ecosystems, and they include smart cities, water distribution networks, precision farming, oil gas platforms, manufacturing 4.0, etc. And common to all of those kinds of problems is this pipeline of interacting processes with interactions that are a mix of physical, human, and machine. And so they span scales that are greater than a single building or a bridge, that they operate at abstractions of multi-scale. And her interest is in how do we get data from these systems and how do we analyze that data from those systems. And she's given 2 examples of the kind of work that they're doing in this grand challenge. The first one of those is work with next-generation water distribution networks. And I know a bit more about this project because it also works with the department that I'm in Imperial, which is the Civil and Environmental Engineering department. And so my colleagues in the water part of that are working with Julie as they're looking at the kinds of networks that we're going to need for water in the future, which are going to involve more sensors on the network so that we can more actively manage the water networks for different kinds of needs for the system. So at the moment, we have rather segmented water networks that tend to be run at relatively low pressure to avoid leakage, but we actually need pressure at certain points in those networks. And so the next generation of water distribution networks is one of the areas that Julie's bringing data science to bear on to understand how we deal with the data as we start to have more sensors on those networks. The other example that she's sharing relates to the conversation that we were having yesterday about food, and she's looking at precision farming and food production and the potential for data science to offer new solutions in that area.
Great. Interestingly, I don't know what this says about Julie, but one of her partners is Ridgeview, which I think they produce wines, I think. Okay, so moving on to the grand challenge that I'm leading, and that's looking at monitoring complex engineering systems, particularly in regard to kind of safety, but also more generally. And when we started framing what we meant by complex systems, especially in the kind of era that we're talking about with data, I should probably say that obviously I talked about underlying mathematical models, but I think George Box in 1978 said that all models were wrong, although some are useful. I think that might be slightly harsh. I think that models kind of maybe range in being useful to very useful, but sometimes are also useless, I have to say. But nonetheless, I think all models are wrong, which is why we need to be so cognizant now of the data that we're collecting and harvest and use some of the information that provides us with. But the data is becoming more and more complex. We're collecting so much observational data that we do have to be really careful about extracting that signal from the noise. So in all of these complex systems, as a framework, although I'll come to actual application areas in the next slide, we're looking at monitoring. That's already been discussed today, so tracking and predicting. Also, it's really important that we acknowledge that a lot of the data that we're collecting is really quite high dimensional and or multivariate. And that's either because of its inherent nature or because we're fusing data now. One of the big projects that I'm working on really is looking at demographic data as well as transport data and looking at the links between them. Of course, these structures are really highly dependent, and that brings about challenges in itself. And a key part of the work that we're doing is thinking about interventions. How can we intervene for safety? I don't know if any of you that are visiting London, how you found things like we're travelling on the tube, but certainly if you travel at peak hours now, it's really, really crowded. And some of the interventions that are put in place to manage that may not be as efficient as they could possibly be if they're well designed. So I work very closely with Dan Graham, another professor in civil engineering, in fact, at Imperial, and he's part of their transport group. And so there's quite a lot of nice data on the road structures and the transport within London. The picture on the left is actually an actual cyber attack, and I'm going to come on to that in just a second. So if it moves forward. So we're working within this grand challenge across 3 particular topics, one being transport, which is not just looking at the kind of transport kind of networks, but also, as I've said, looking at some of the demography behind that. I think that we did a study looking at deprivation and accidents, for example, and if you're looking at how roads are designed, certainly in London, I cycle from Camden, or from Holloway, in fact, I have to be honest. I cycle from Holloway or down to South Kensington, and in terms of the safety infrastructure between those 2 boroughs, it's really quite marked. And we've done quite a lot of work looking at whether you're safer in particular areas related to their deprivation. And a lot of that is about political influence, and certainly in Barnsbury, a very nice area of Islington, they tend to be very good with putting in their safety intervention measures on the roads that don't exist elsewhere. So I think that's something we want to look at. So interventions and adaptations, and looking at the general inference methodology. We also have a cybersecurity theme. We're very lucky to have Niall Adams and Nick Hurd, who work very closely with Heilbronn and GCHQ on cybersecurity and actually identifying that, which is really a huge safety risk, I think, to us. And again, we talked a little bit about Cambridge Analytica and that balance between information safety. And then also a methodology theme, because that is very important. I think we have to get the underlying methodology right. We have to understand what these machine learning algorithms, these AI processes are actually doing. Right.
So the theme that I'm leading is around data-driven engineering design under uncertainty. And we're just at the outset of this theme. The themes will be around infrastructure, around complex systems, and around people-centric design. And really, in my day job, at Imperial, then I lead a Centre for Systems Engineering and Innovation. So we're very interested in systems. And in leading this theme, I'm very interested in how we can use data to understand infrastructure, complexity of systems, and people-centric design. We've got to focus around a range of topics around predicting systems interactions, potential failures, model integration, problem structuring and scenario generation, bringing knowledge from operations into project delivery, managing design change, sensitivity analyses. And we've got a range of projects that we're setting up. And just to give you a flavour of that, I've put a number of them onto the next slide. So we're looking to do some work taking learning from across the Crossrail projects. So I've done a lot of work with Crossrail, which will become the Elizabeth line in London. And we're looking to understand their design data to inform the next project, Crossrail 2, that's just in the process of setting up. We're looking to do some work around urban mobility. We're looking to do some work on the digital twin. And here we may work with another of the major infrastructure projects, High Speed 2. We're involved in co-organising an event at the Institution of Civil Engineers between the Data-Centric engineering programme and the ICE, and also Tech UK, which is going to look at AI in infrastructure. We have visitors at the Turing Institute that are attracted internationally, who are coming to do work with us on things like modelling and simulation of resilience, and are setting up experiments at the Turing Institute over the summer. We've been doing some work with the KTN on complex systems engineering framework. We're looking to do some work on design for retrofit, and there's also some work on BIM queries. So how do we query the data sets that are developed in design to better understand and to be better systematize them to be able to do the kinds of data science that we want to do.
And finally, I want to talk a little bit about education, because I think that one of the challenges that we have with data science is that at the moment we're not really geared up through our education system. And that's true not just at, I'm going to talk about at the kind of PhD training level, but actually that's true kind of across the board. I think it's true all the way through our school education as well. We need to do much more in terms of embedding data science into disciplines, for example, and that involves a lot of training for teachers, but that's another one of my kind of pet projects. So in terms of what the Turing are doing, I really just want to highlight a couple of things here. One is we have an MSc in statistics at Imperial that's proved very popular. We're looking to start up a data-centric engineering stream as part of that. We have a data science stream already that's going to start from October. We've also put in an application for a Centre for Doctoral Training in Data-Centric Engineering, and that's really across several departments at Imperial, including mathematics, civil engineering, computing, and so on, chemical engineering, and a range of departments. We're actually running Darren Gray, who's the program manager, is setting up an industry consultation workshop in June 2018, because I think it's important that we speak to industry. We've already had some communication across what the needs are from industry in terms of the training for that program. And if we get through the first stage, the announcement should be made quite soon, in the next couple of weeks, then we're going to submit a full proposal by July of this year, and hopefully that will be successful. And that's us. Thank you very much.
Thank you very much, both of you. I think that double act worked rather well, actually. So, opening for questions. Anyone like to ask something? Yeah, yes, if you could just wait for the microphone to come, please. Thanks.
BIM. It's really interesting that Crossrail's been delivered with this ability to map London that didn't exist before, plus or minus, I think it's about 5 centimetres for the tunnels. BIM's actually a multi-layered thing, and I've seen it drill down and have applications not yet used in cyber. Does that marry safety and in security together in some form, and is there a future in it?
I mean, I'm deeply engaged in some of the conversations about data, and of course security is part of that. And actually there is the link being made between BIM and safety. I think there's a lot that the infrastructure industry can learn from other areas of manufacturing which have been using PLM, and actually I think there's some cross-learning that can go on there. But I think there's a really interesting journey, there's a really interesting sort of potential for a leap forward, because people have thought about these systems as helping individuals collaborate, but as they've aggregated more data, then there's the potential to do more with it, and to understand design better, and to bring design and operations closer together, to do things like design for predictive maintenance. And so I think that there's a really interesting landscape of research that's beginning to move some of these areas forward.
So I've got one small question, which is you've outlined lots of examples of challenges that are of huge public interest. But of course, one of the challenges is also engaging the public in a meaningful way. Do you have any kind of comments on that? Or, any thoughts on how that should be done?
how it should be done. I think I think it is a really challenging kind of question. I think it's one that Turing hopefully is going to become more engaged with as well, because I think that it does there's all sorts of things in terms of outreach activities. In fact, the last picture that I had, oh, never mind, actually was taken from the festival. Imperial College runs a summer festival that just happened last weekend. And that gives us a really good opportunity to kind of get the public engaged in some of the research that's being done. And certainly that's...
The ImpFest.
Yes, exactly, yeah. So Imperial Festival was really, really amazingly well attended. And I think that obviously contributions that we can make there. I actually think what we need to do is sort out our education, I think. And then I think that becomes, I think that we need to embed it all the way through from primary school, really, I think, a lot of these kind of things.
Easy, sort out education.
Sort out, big tick.
Any more questions? No? Okay, well, thank you both very much for a very engaging
Thank you.
discussion. Thanks.